Hello students, now I will tell you the origin of X-rays, how these X-rays are produced and what is the origin of these X-rays. We all know that the fast moving electrons emitted strike with the target, and target has the number of atoms which have the electron moving around the nucleus. The target have a large number of atoms which have electrons moving around the nucleus in discrete energy levels. When a fast moving electron strike the target, it enters the family of atomic electrons where it experiences the repulsion force, the Coulomb repulsion force. Due to repulsion force, the electron is retarded continuously, and it loses its kinetic energy. Which appears in the form of X-ray photon. So what we have, that suppose this is the nucleus, positive charge nucleus. It is having these electrons These are the electrons. Then this is one more orbit. It is having so many electrons. एक दो तीन चार पाँच छः सात आठ नौ 10 11 12 13 14. And now what happens here, that when the electron is coming here, this is the electron, it is moving electron, then this enters this family, and then it is like this. This is the electron, and it loses the energy that appears in the form of photon, h nu. So now this energy is supposed E, and this here the energy E1, this is now energy E2. So initial kinetic energy of the electron initial kinetic energy of electron E1 equal to half m v1 square. After retardation, during retardation, the kinetic energy E2 equal to half m v2 square. So loss of kinetic energy will be how much? So loss in kinetic energy is equal to E1 minus E2, and this is equal to half m v1 square minus half m v2 square. And let energy of X-ray photon equal to h. So following the law of conservation of energy, we can say that this by law of conservation of energy, what is to this one, that this h nu is equal to half m v1 square minus half m v2 square. So you can see from this equation that as the value of V2 decreases, this energy will increase. From above relation, it is clear that as velocity v2 decreases, the energy h nu will increase. And if v2 is equal to 0, then h nu is maximum, that is equal to half m v1 square. So this phenomenon it is called Bremsstrahlung. So the electron continuously lost the energy. Or h c upon lambda minimum equal to half mv square. Let the electron is accelerated by potential difference of v volt, then half m v1 square equal to ev, where e electron charge, hence hc upon lambda minimum equal to ev, or lambda minimum equal to hc upon ev. Now if you put the values of the constants, lambda minimum, this is equal to 6.64 into 10 raised to the power minus 34, and this is 3 into 10 to the power 8 upon, this is 1.6 10 raised to the power minus 19 into v, and there you will find this lambda minimum equal to 12,400 upon v angstrom. So lambda minimum is proportional to 1 upon v. So what we have, if suppose this is your lambda minimum and this is now applied voltage V, you will find a curve like this. This shows that as the voltage is increased, lambda minimum decreases. So thus the energy of the X-ray photon can be increased by increasing the potential difference. Or if we have this here, lambda minimum, and this is now 1 upon v, then we will have a straight line, lambda minimum proportional to 1 upon v. This is the origin. So you can say that the minimum wavelength of the X-rays depends upon the potential difference. Thus, lambda minimum of X-rays depends upon potential difference between filament and target. It means that if suppose we have taken, and also you can see that this lambda minimum is not depending upon the material of the target. Lambda minimum does not depend upon nature of material of the target So whatever be the material, minimum will be same if the applied voltage is same for the different material. So it can readily be seen that for different targets, the lambda minimum will be same when the applied voltage is equal. For same potential difference, the lambda minimum will be same for all materials of target. So you can see that when the energy is continuously continuously decreases, then there is continuous increase of the energy of the X-ray photon. So in continuous decrease of the kinetic energy, this is called the phenomena Bremsstrahlung. So thus you see that due to the retardation of the fast moving electron while striking with the target, there is the origin of the X-rays. So you all like, share and subscribe this video. Thank you.